Welcome to the taster session on BTEC Engineering Level 3. This course is designed for those who are pursuing a career in all types of engineering, be it electrical, aerospace, mechanical, any type of engineering. Those who are wanting to go on to university and study engineering. All universities offer different engineering courses, and it's a wide variety of opportunities after studying engineering. And it's for those who are interested in applying science and maths to solve problems. This is the core of what engineering is. So this qualification can lead to lots of different career options. There are lots and lots and lots of different careers that engineering, a qualification in engineering opens up. You could be an engineering operative where you work in a plant. You could be a manufacturing operative. So that means it could be maintaining factory machinery. It could be designing manufacturing factory machinery. It could be an electronics technician. It could be electrical engineer. It could be going to be an electrician. Could lead to other things such as an aerospace engineer, so looking at designing and maintaining planes. Could be an IT support technician if you're interested in the computer programming and computer support side of engineering, and of course as an electrical engineer as well. If you're wanting to be some sort of electrical engineer, there's lots of opportunities. There's also the mechanical side of it, mechanics working with any machinery or engines. It is a massive, massive field, and it's one of the most interesting fields to work in. There are plenty of higher education courses as well that I've previously mentioned also. So there is, you could do, these are possible degree courses that you could do. So there are a range of degree courses. You could do an engineering degree, or you could do a science degree. So you can just do a straight engineering degree at university. It could be that you do electrical engineering. There are a variety and lots of little facets to this and modules that you can do. I myself was an electrical engineer. I did electrical engineering and electronics at the University of Liverpool. And I studied robotics, computer programming, along with three-phase systems and electronic circuits. I also did a lot of lectures with the aerospace engineering students. So there's a big overlap between the different engineering disciplines. A lot of this is also based around maths as well. So it's good to bear that in mind, that being a strong mathematician will help you on this course as well. You can also get a Bachelor of Science degree if you did computer science, or you looked into more the science route of engineering. And there's mechanical engineering, which is a massive side. So that's mainly your what you would class as your engines and mechanics side. And there's civil engineering also. So civil engineering is big structures such as bridges. There's a lot of engineering in roads that people don't think about. Buildings, tunnels, lots of things like that where you can get involved in. And the massive, massive projects at the minute, such as HS2, that will be going ahead at some point. So that's a massive project, and there'll be lots of career opportunities there. We've got Sellafield nearby, so that is a big engineering. It's a nuclear engineering, so lots of opportunities there. So engineering is a great career to get into. Along with this course, you don't just get the qualification, it will develop your employability skills. So these are the skills that aren't necessarily something that you are just taught. It's something that you pick up and you develop. So one of the first skills is cognitive and problem solving skills. So as an engineer, you have to come up with a solution to a problem, a practical solution to a problem. That's sort of the fundamental purpose of an engineer. So you've got to think of how practically you can solve an issue that has been given to you. One of the other skills is interpersonal skills. So as an engineer, you have to work alongside lots of other people, and you'll have to work with other people to develop these problem-solving skills and to solve these problems that are put in front of you. So you have to be able to communicate clearly and have good teamwork. So this is one of the key skills to being an engineer. And also on the course, you will develop your intrapersonal skills. So these are your personal skills. So these are what makes you, so this is your resilience, your analytical thinking, what makes you you. You will develop these skills that are sought after by lots of employers, not just engineering employers. The course is assessed over time. So most of the modules are internally assessed written assignments, although you are required to keep a logbook and your notes of all that you do. Some of your construction projects will also be assessed. So that's looking at what you've made, what you've developed, what your plans were, and then judging that against set assessment criteria. And throughout, you'll need to keep suitable written work that shows your development of your knowledge. So this could be written assignments, it could be essays, it could be research that you've done. It could come from a wide range. It could be photographs of what you've been doing. It could be films. It could be written reports, feedback from staff. But it's important that you keep a log. It's like a learning journal of what you've been doing. This all goes towards your final grading. It's important to know that there are no formal exams for this course, which is quite appealing if you're not somebody who likes exams. The course has a structure which has 2/3 of it, which are mandatory units. So these are units that you cannot change, and you must do these units. So these are mechanical principles, delivery of an engineering process, product design and manufacture, electrical and electronic principles. So mechanical principles would be looking at forces, how machinery works, and why it works. The second point, delivery of an engineering process, is looking more deeper into what engineering is, how a product can be made, the engineering that goes into making a product or a process, and there's a lot of research involved in that part. There's also product design and manufacture, so you will have to design and manufacture a product, as it quite clearly says. So you would have to think about how you're going to engineer the product, what materials are you going to use, what is good about them materials, what processes you need to do, and look at the efficiency of the manufacture of your product. So it's not just about how to make it, it's about how you can make it efficiently, what is good manufacturing, and what is good quality control. And then lastly on there is electrical and electronic principles. So electrical and electronic engineering is a huge side of engineering. Everything today has some electronics in it, and nearly everything is electrical. So it's looking at the basics about electrical engineering. So that will cover things like Ohm's law, how to install electrical circuits, what is safe with electrical and electronic circuits, and really looking at the safety behind that as well. There are lots of optional modules that can be taken, and this counts for 1/3 of the course content. So these are just a few of the elements that could be taken. So there's computed aided design engineering, so that's CAD engineer. So these are much sought after, CAD engineers. So this is designing on a computer 3D drawings of engineering projects that are using engineering products such as plans for buildings, could be plans for railways, but it is a really important part of any engineering project. Every engineering product needs some computer aided design. And there's electronic devices and circuits. So this is looking at how you can use electronic components to solve a problem, and what circuits are and how you can safely wire circuits. This is more and more important as we use more and more electronic devices. Third is computer programming. So this is a massive section of engineering. Even though it doesn't say engineering, computer programming is still engineering. It is one of the most lucrative sides of engineering, and it is quite a popular side to engineering. There's also engineering maintenance. So engineering maintenance is looking at maintenance schedules for big projects. So at places like Sellafield, they will do a lot of maintenance. A lot of their engineering will be maintenance and making sure that everything's running smoothly, all the machinery works correctly. So all factories, all buildings will have engineering maintenance engineers there. So it's a really key side to engineering. There's also microcontroller systems. So this is using small electronic computers like microchips, and how you can use them just to do small control circuits. So how you can program something that controls a bigger device. And then lastly is calculus to solve engineering problems. So this is a maths-based. Calculus is Greek for pebbles, which were what they would initially use to count. And calculus is a huge side of maths. So it's to do with differentiation and integration. It was developed by Sir Isaac Newton. And that's how calculus is used to solve engineering problems. Calculus is really, really important in engineering and in science and maths overall. So it's a really good optional unit to take. But there are lots of other optional units that can be taken depending on what you want to cover and what you want to go into. Right, you have 20 minutes to do the following. I would like you to find the names of 5 engineers and research their greatest achievements. So you can use your phones and just have a look and see what type of engineers are out there. See if you recognize any of their names. See if there's anybody who you think, wow, I know who they are. And then write a brief definition of what you believe engineering to be. If you pause it now, and if you come back in 20-25 minutes. So this is my definition of engineering. Engineering is the combined application of maths, science and technology to design and construct solutions to complex problems. So engineering for me is how do you use maths and science and technology all together to overcome something that you've been given a problem that you must do, that must be overcome. It is the amalgamation of all three. You can't have one without the other for engineering. That's why it's such a sought after skill and sought after career path. It is really one of the ultimate subjects that you can cover. And here are 5 of my favourite engineers of all time. So this is Tim Berners-Lee. So Tim Berners-Lee, he engineered the internet. So he was the first person to come up with the idea, and he set the whole internet off. And if you think about what the internet is, that I'm using this now to record, I'm using it to record this broadcast on what everybody uses, how much it's used in life now, and would be completely lost without the internet these days. It was all down to, well, mainly down to this person, Tim Berners-Lee, who had the vision and the resilience to come up with such a amazing idea, and then put it, not just come up with the idea, but actually build it and put it in motion. The second engineer here is Isambard Kingdom Brunel. So Isambard Kingdom Brunel will be the greatest engineer of all time. He built boats. He was the first person to come up with the idea of bulkheads. He designed the first steel ships. He built some of the greatest bridges. There's a picture there of the Clifton Suspension Bridge in Bristol, which is still used today, even though it was built nearly 150, 200 years ago. He's got the high level bridge across the Tyne in Newcastle. He came up with built a lot of railways. He had his atmospheric railway, which used suction to pull trains along. He's engineered so many things, and he's revolutionized the world in Victorian era and the late Victorian era. His steamships that he created meant that we could trade with America quickly. So he developed the economy of this country as well. There's a university in Leicester named after him, clearly called Brunel University, which is just pure engineering. So he is the greatest engineer of all time, as far as I'm concerned. And then here's another engineer who people don't know, but he's saved so many lives. His name is Percy Shaw, and he invented and engineered the cat's eye that you see in roads. He famously didn't make any money out of it. So although there are millions and billions of his product all around the country and all around the world, he's never made a penny out of it. Yet he made such a simple idea, and he engineered it so that it's used throughout the world. It's used all over the world, and it is one of the most elegant engineering solutions that there is to a problem. So simple, so cheap to make, yet so effective. The next one is Alan Turing. So Alan Turing, he engineered the first computer. So Alan Turing was a mathematician and he was not computer scientist, but he was a logician. So he looked at logic, and he was into electronics as well, and electrical engineering. So he worked at Bletchley Park during the Second World War, and he worked on a machine called Colossus, which was used to decrypt German messages from their U-boats, and it enabled the shortening of the Second World War. Alan Turing alone is meant to have saved over 8 million lives just by shortening the war, because of his prowess and the fact that in the process, he engineered the first computer. So he engineered the first computer. He eventually went on to, unfortunately, he killed himself because he was gay. He was sent to prison by this country, and he was persecuted by this country where he saved and he shortened the war. So he ended up putting poison on an apple and eating it. Thus you get the what looks like the Apple logo, with an apple and a bite out of it. Although Steve Jobs, who was the leader of Apple, he said that that's not what the logo is for. He said he wishes it was. And then last of all, quite a strange character, Elon Musk. He may be a bit bizarre, and he may be outspoken, and he may have some strange ideas on the world, but he has to be one of the great engineers because he engineered the first commercially viable electric cars. So he is saving the planet, and he's engineering spacecraft, and he's reaching out, he's making humanity, and he's changing humanity with his engineering. So he's got to be applauded for that. even though he does have some strange ideas. These are some of the great engineers, and they've got great ideas, and they show what engineering is really about. It's about finding a problem, applying maths, technology, and science to it, having some resilience and keeping on going, and then applying it and finding a solution. So that is ultimately, to me, what engineering is, and that's what these people signify. So this course is a great course if that is what you're interested in. It will lead you to lots of other things in the future. There are lots of exciting opportunities with engineering, and they are great. I'm proud that I'm an engineer, that I did engineering at university, and it's something that I love, and it's something that's one of my passions is engineering. I hope you enjoy doing the engineering course, and I hope you take it up. Good luck. Thank you.